Hello and a warm welcome to you, Junior Takis. This is your host, Mr. T, and it brings me joy to be presenting to you a lesson focused on Euclidean geometry grade 10. In this specific video, we're going to summarize similarity and congruency. So to kickstart, we're going to look at similarity. So in theory, two triangles or two shapes are regarded as similar if they have the same shape but different sizes. In other words, one has been magnified, one is larger than the other. So to help me present this to you, I'll have two triangles, namely triangle ABC and triangle DEF, as you are seeing, with the following marked angles: 60 degrees, 80 degrees, 70 degrees, 70 degrees, and 80 degrees. So those two triangles, you can see that the corresponding angles are equal. However, visually, triangle ABC is much larger than triangle DEF, implying that we are having the same shape but different sizes. So what conclusion can we make based on what you're seeing right now? We can make a conclusion that triangle ABC is similar to triangle DEF. The reason for that is angle, angle, angle. So we've used angles only to prove that the two triangles are similar. But that's not the only way to prove similarity. We can look at case number 2. And in case number 2, you can have the same two triangles, triangle ABC and triangle DEF, with marked sides as follows. So if you look at those marked sides, the angles are no longer given. It's now the sides that we know. We know the magnitude of the respective or the corresponding sides. We can make a conclusion or write a following statement to say that the side 5 over 10 is equals to 6 over 12, which is equals to 8 over 16. The conclusion is that, therefore, triangle ABC is similar to triangle DEF. But the conclusion this time around is that we say the sides of triangle in proportion. So the sides of triangle in proportion. We then move on to the next part, where we explain or summarize that similarity can arise if corresponding angles are equal. So corresponding angles have to be equal, which was your case number 1. And case number 2, where corresponding sides are in the same proportion. So these are the two cases that we deal with when you're looking at similarity. Number 1, either corresponding angles are equal or corresponding sides are in the same proportion as you saw. We then move on to the next chapter, which is congruency. And with congruency, I'm just going to summarize the conditions of congruency. So with congruency, they have to have the same shape and size as well. So same shape and same size. These are almost like your twins. They have to be equal in everything. So let's look at the conditions of congruency. For two shapes or two triangles to be regarded as congruent, the conclusion that we can make or that we can use is that we could use the condition of RHS. In other words, we'll be given a right angle, a hypotenuse, and a side. That's RHS in abbreviation form. Number 2, we could be given 3 sides. That is side, side, side. The third one, we could be given a side, an angle, and a side. The last case is whereby we're given a side, an angle, and another angle. All these 4 rather, form the acceptable conclusions under congruency. So whenever you're dealing with a case of congruency, one of these 4 reasons will be true to whatever case you're dealing with. So it is imperative that you remember these conditions and you know when to apply them. It's not a case of just picking and going. You've got to know which one is true to the condition that you've been given. I hope you enjoyed that lesson. Until next time, bye-bye.